Okay, here's a question from the 7-2 homework. It's question number 17. You've got a steel rod manufacturer, and the mean length of the rod that the manufacturer produces is 27 centimeters, but there's a little bit of variability in the process. So it's it's standard. Sorry, it's not standard. It's normally distributed with a standard deviation of 0.6 centimeters. And this is something that real manufacturers have to worry about, is that their equipment can't really produce exactly the same thing every time. There's a small amount of variation. Now, in modern age, it's gotten small. The variation's gotten smaller and smaller, but it's still there. So for really exact purposes, depending on what people are manufacturing or what they need the steel rods for, you have to worry about how close you're getting. Okay. So the first one's I opened StatCrunch over here on the right side of my screen, and the first ones are pretty straightforward. What proportion of the rods has a length less than 26.9? So I just key in the mean and the standard deviation in my calculator here and ask it what's the probability that the random variable here, which represents the length of the steel rod, is less than 26.9. Okay. And so what do we get? We get about almost 5%. Okay, so rounded, that's the number here. The person that asked the question, though, was asking more about B and D. B is a little trickier. It says any rods that are shorter than 26.88 centimeters or longer than 27.1 are discarded. What is the proportion of rods that will be discarded? So we can do this two ways. The problem is that if you use the standard tab, you're either finding a wing above or the probability of a wing above or a wing below, depending on which way you face. You see where the red shading is? So I'm either getting the probability of getting below 26, or here the probability of getting above 26. Okay. And likewise, when you do the between calculator, let's see, shorter than 26.88 or 27.12, we're getting the shaded region to be in the middle, the probability that we have a rod between these two values, right? But what we really want is the opposite of this. We want this to be red and this to be red. So StatCrunch's calculator won't compute that directly, but using what we know about probability distributions, that the whole area under the curve has to be 1, right? We know that if I just take this number and I subtract it from 1, I'll wind up with this number right here. Okay, so really, these little white regions, which are the regions we actually want to find, right, are the complement of this red region. Unfortunately, we can't compute that directly, but we can just subtract this number, 0.954, blah, 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 from 1, and get this number here. I hope that makes sense. The other way to do it, of course, would just to be, you can find one of those little areas. 26.88. Whoops, 26.88. Right, that's one little end. Then you find the other little end, and you can add those two together to get that. That's the other way to handle it. Okay, I'm going to skip down to part D because that's the other one that was giving people trouble. You have an order for 1,000 steel rods coming in. The order states that all rods must be between 26.9 and 27.1. So let me find the probability. 26.9 and 27.1. Okay, so about 90% of the rods that we make are going to be in that range, right? But not all of them. So the question is, how many rods do we have to manufacture to make sure we get 10,000 of them? Okay, And really, we have to make more than 1,000, right? If 10,000, if we made 10,000, we're only going to get 90% of those, like 9,000 that are meet our specifications. So we actually have to make more than we need for the order to make sure that we get 10,000 of the, of the exact, or within that range from 26.9 to 27.1. So all we have to do is, it's just an equation, right? You take the, what is it? The number you want, 10,000, and divide it by the percentage, which is here 90.044193. Okay. And so that gives us about 11,056, almost 57, but I think 11,056 is all we need to get 1,000, to get 10,000, sorry, good rods. Ooh, I guess they round it, round up to the nearest integer. So they say round this up. That makes sense. Yeah, you'd have to round up to make sure you get that full 10,000.